softwares and what robotics is all about, I decided to bring out these materials. And then if you are with the materials, you can go through the materials, and for the sake of time too. So now, let's look at the topic, robotics in industrial automation. So I first of all bring out robotics. So let's talk about robotics. We all know that robotics, to me, before I go to the materials, according to my research, to me, robotics has to do with the assemblance, the building of a robot. And then let's look at the materials. Talks about robotics is an interdisciplinary of engineering and science that includes mechanical engineering, electrical engineering, computer science, and technology to design, build, and operate robots. So with these few destinations, I believe you have the knowledge of where robotics is coming from. Robotics do not just stand on its own and start like, they do not just stand on its own and form itself. There are branches of engineering that comes all together to build a robot. So for it to be a qualified robot engineer, you need to play along all these fields. You need to play along all these fields. And then now, robots, let's look at what robots deal with. Robots deal with the design, constructions, operations, and use of robots, as well as computer systems for their control sensories, feedback, and information processing. So these are things you need to know about robots and know what robots deal with. You can use robots for constructions. You can use robots for controls and sensories. You can also give feedback also, and you can also process information. I'm just giving you a brief history of robots. Now, before we still go into the topic of the day, which is the themes. So we can also look at the aspect of robots. Can also look at the aspect of robots. All robots contain some levels of computer programming code. So after all this engineering might have come all together to build this robot, electrical, mechanicals, and then computer science engineering. So computer need to be programmed so that it can function. So there is a particular code we can use to program a robot. So now let's look at what a program is all about. A program is how a robot decides when or how to do some things, do some things. Program has the core essence of a robot. It could have excellent mechanicals and electrical constructions, but if the program is poorly, or if it's poorly programmed, what happens? No matter how the construction perform, no matter how you construct the robot, but if it is poorly programmed, that robot might not function. So from the materials I talked about, is programs are the core essence of a robot. It could have excellent mechanicals and electrical constructions, but if its program is poorly, constructions, its performance will be very, very poor, or it may not perform at all. So now, what makes a robot to function or to do something according to how it is being designed? It is a program. It is the programs of that robotics. So now, a robot as a whole is only programmed to do a particular task. It does not just, okay, this robot will do all the tasks. No, it has a specific task it needs to be programmed for, and it works and acts according to the programming. So now let's look at still in the aspect of robotics, we have artificial intelligence, which is AI, and decision making. So now this aspect focus on how robots process data, and make decisions. It includes areas like machine learning, path planning, task planning, and problem solving. This determine reactions to objects and problems solving, and reactions to objects and problems they encounter using their pre-existing programmings. Now we have what is called hybrid. Is a forms of programming that incorporate both AI and RC functions. Now these are the things that you need to know about a robot and the essence of its programming. So now we talk about in still the aspect we have a sensors and perceptions aspect. Now this aspect involves how robots perceive their surrounding through sensors like cameras and ultrasonic sensors, etc., and process data for tasks like object detections and navigations, etc. Now I'm just giving you a brief history. So we'll go to the main subject of the day. So now let's talk about another aspect which has to do with actuators. You know about robots. A robot has a sensor that can help him to detect objects and also perceive objects depending on its program. So now let's look at actuators and controls. This aspect is how a robot moves and interact with their environment using motors and actuators and control system. This aspect covers how robots are controlled to perform tasks and grasping objects and moving limbs. So now the robot has several. It has a hands, it has a leg. So what helps the robot to move and also to move is the leg and the hands, and even the body and the neck. It has to do with what's called actuators. So it could be any actuating systems, and it could also be uh, and motors. We have several types of motors as far as robotics is concerned. We have the servo motors, and then we also have a stepper motors. But in a robot, what is mainly used, there are some robots they use stepper motors on it, while some robots can use servo motors. That servo motors move in, let's just say, in linear form. So it helps you to pick objects from here and drop to the other side from left to right. So now we also look at autonomies and navigations. So this aspect covers how robots move and operate independently. It's not all robots that require human control. So this type of robots, they can move on their own, do the tasks on their own, according to their programming. So now it includes navigations techniques like mapping, localization, path planning, and obstacles avoidance avoidances. So what you need to understand that there are some robots that can use to track. You can use it to track locations. You can also use it to track a particular, let's just say, a vehicle. There are some smart vehicles now. Let me just, I use a cyber truck as an example by Elon Musk. So Elon Musk have built this truck in such a way, have built this truck, cyber truck in such a way that if that truck is being stolen and you can track the trucks, you can track it because it's very smart and it comprises both the artificial intelligence actually. So now let's look at human robot interactions. That is HR. Human robot interactions. This has to do with how the robot interact with humans. This includes interfaces like voice, commands, gestures, displays, etc. And designing robots to work safely and effectively with people. You know, some robots could be dangerous if you don't program it and tell them that this particular object you are seeing is a human, and this is how you should interact with humans. There are some robots that are built for war fronts, militaries. There's robots that are built to help humans in terms of house choice and cleaning and then washing, etc. So now this type of robots interact with humans. So we are still at the aspect of robots. So let's look at the types of a robot. Now we have service robots, and this is a type of robot that it is not. It is a it assists human in non-industrial tasks. This has to do with example like cleaning, deliveries, and healthcare. So the way I make these webinars, I make it very clear. I make it very simple. If some of us who might not really have a good network to follow up all the discussion and all the works, there's a materials you can follow up by going through the materials. If you have any questions and the rest of the things, can also discuss it. Let me know. So now, the second one is humanoid robotics. This humanoid robotics give you like a form of a human. It's just a human like. So it is built to interact with human, friendly, very friendly, and then etc. So we have area robots. These robots, they are the drones we are using. Drones, for example, drones. And then we have underwater robots, and then we have medical robots, and then we have military robots. Underwater, we can use it to send an instructions to a pipeline in the waters, and then you can tell it, okay, where as you are going, you can carry out a certain maintenance, a certain maintenance on the pipeline that is running on the underwater. So this type of robot can be used on that approach, and they can also use them to send for an inspection. So now we have a medical robots. And there was this video I was watching. I saw as these Chinese people, they design a robot in human forms. Okay, they design this robot in such a way that it is very intelligent enough to carry out an operation on a theater. I was so surprised. And the man that was interviewing there was like, I say, would this not be very dangerous? He said, no, it can't be dangerous to him. He can carry out his work accordingly. So this type of robots, you can find them in medical. So there are a lot of robots in medical sectors that can be used to carry out an operations on the human body also. So we have a military robot. You will see a military robot in such a way that you can send in this military robot for bomb detections. You can also use it to fly, and then you can fly bullets against your enemies, and this robot can be used to fight against the enemies. It can also be used in the war front as well. So now, because of times, we have agricultural robots. These robots, the one we know, agricultural robot example is the tractor we have been using to harvest our crops and then to plant our crops. So now, this is discussion for today, which is robotics in industrial automations, applications, and future trends. What I would like us to look at is the introductions to robots in industrial automations. Now, robotics in industrial automations involve using robots to automate factoring, handling, and inspections and more, safeties, and reduce operational costs. Reduce operational costs. So now we have applications of robotics in industrial automations. Applications of robotics in industrial automations. This has to do with the tasks that a robot is doing in our industries. It's not just like a robot is just being assembled or is just there in the industry without doing anything. So we need to know the applications, the works of a robot. What is this robot doing? What are they doing in our industry or in industries? So now, robots assemble complex products with precision and speed. examples. We have common example. We have the robot common in automotive industries. We also have them in electronics and other machinery sectors. First of all, let me pick the automotive industries. These automotive industries, they found the main types of the robot that is being used in these automotive industries. They are robotics arms. These robotics arms, they build them in such a way that they resemble the human hands, and they have a lot of they have different types of programming as well. And then these robotic arms, their applications in automotive industries or manufacturing companies, they serve in screwing. They can use to screw. They can use to screw a nail, a nut, or a nail. They can also use to sanding a body of a motor, a car, and they can also use to paint the car, like to spray the car, and they can also use to assemble and disassemble a car or any vehicle that is being manufactured. Now, let's look at this in electronics. This robotics, they just have as robotic arms. They can use to unscrew and also to assemble some of our electronics equipments, so appliances as well. And machinery sectors, there are some types of machines you cannot lift by your hands. You cannot lift, a human cannot lift or carry it from one place to another. So it requires a robot, and every robot that can carry this object to a particular destinations. Now, we have materials handling. We have materials handling. A robot is also designed in our industry to handle materials. So now, what is meant by materials handling? Robots move heavy or delicate items efficiently, improving safeties and logistics in warehouse and factors. So this is to tell you that a robot help us to move our words. It helps us to move our heavy items, heavy objects from one destination to another. So this type of robotics, we can also call it a conveyor belt. A conveyor belt is a typical example of a robot that can move objects from this point to another. And this conveyor belt, no matter how the object is no matter the shape of the object and how heavy the object is, you can move this object to any destinations. So now we also have a warehouse factors also, like logistics in a warehouse. Like I said, a conveyor belt can be connected from this manufacturing or to a warehouse where those products can be stored. So a robot can handle this particular task as well. So let's look at welding. Let's look at welding and then qualities. Let's look at welding and cutting. Welding and cutting. Robot doing spot welding on car assembly line. This is a typical example of a robotic arm as well that helps to carry out. Hello?
Yeah, audible, sir.
Yeah. Okay.
You can continue.
Can you hear me now?
Yes, sir.
I believe I'm audible. I'm audible, right?
Yes,
okay.
You're audible.
Okay. Now, I was talking about welding and cuttings of products, of goods, of any materials. Now, robot is also designed to be doing this spot welding on a car assembly line. So now this to tell you that a robot has a very vital role to play in our automotive industries. It can use to do what assemble and disassembles our cars. They can also use to well an object. Can also use to well an object also. So now, even the car, that it is a robot that is carrying out that is carrying out the welding in our automations or in our automotive industries. So now, quality inspections. We have quality inspections. Now, in these quality inspections, um, a robot with vision systems inspecting products on a conveyor belt. We can build a robot in such a way that has a sensors in our conveyor belt that is carrying a product from one destination to another to monitoring to monitor this object. They can build this robot in such a way that it can help in counting this object, or it can help you in counting this product in our conveyor belt. We can also use to detect when an object is coming and when an object is not coming. So it's not moving on the conveyor belt. So we have key industries. There are some key industries that are benefiting from this robot. Key industry benefiting from robots are from still the materials I said. We have automotive, with what are they doing? Weldings, assemblies, and painting. So a typical, I have a robot in the house and I did not assemble it. I have a robot in hand because of my work, nature of my work. I don't really have time to uh, run a coding on the robot. I don't even assemble it also. So just give me a second. Let me show it to you. All right. Hello. Can you hear me?
Yes, sir.
Okay.
Yes, we
So
can hear
this.
you.
So okay. This this is a robot. Please. There's noise on the background.
We can see it, sir. We can see it.
Okay. This is a robot, and I haven't assembled the robot yet. And this is a robotic arm as well. This robot can functions in welding, can also functions in picking objects from one. And also we we have, because of our time, we have electronics industry, electronic industries for precision assemblies. That's you can use it to schools for electronics, you can use it to assemble, you can use it to design the components. And also can you also use it for inspection. Beverages that are using robotics, such as the conveyor belt, and then some of the robots that help for packaging of our items. Playing softwares and controllers, which you can use, which industries are using to control also. Now, I mean, that one is not part of is not part of our material. So now we have food beverages, we have industrial line, which we can use it to detect object, color of an object. That is where the sorting fall in. If red is to move on the right hand side, there is a particular system you can view with actuator. You push the object to a particular channel of the conveyor to according to its color. And if it is red to the right hand side, if it is something like white, okay, allow it to pass straight to a particular direction. So now we can view a robot in this particular form also. Now we have logistics. We have logistics, this logistics and warehouse is transferring of objects from one point to another. So in this particular aspect, before I go into the future trends, before I go into the future trends, there is a controller used in an industrial line, because discussing like this might feel like okay, I'm just quoting it. It's something that I play with, something I also have time with. And then I also now there is a controller for a PLC, and PLC is a programmable logic controllers. Now this PLC has a software, and we have different types of PLC as well. We have Alebranley, we have Siemens, we have ABP, we have Mishimbushi, etc. So these types of the controllers, they can program. They have different programming language. They have different programming language. But the one that we are very much familiar with, industries are familiar with, even the automations guys are familiar with, it is a linear logic program. Now, this linear logic programming, we can program it in such a way that it helps you to count the numbers of product that is moving on the conveyor belt. It also helps you to package a product. It helps you to package a product in a particular carton. For example, let's say in a Lipton tea, we have 24 Lipton teas in the pack. Now, there is a robot you can be a systems in a conveyor belt that can carry out the stack, which is with the help of counter. It moves each of the items to the pack. By the time you move each of the items to the pack and package it very well, and it will channel it if you reach the limit, let me say like 20 product, it is 20 product that should be put on this pack. Now it will count it accurately without any mistake, without any addition. 24 product, it will put 24. If it's 20, it will put 20 with the help of counter. It has additions and it also has multiplication. This is a PLC software that we can use to carry out that program. Now we also have a timer. It helps to move our product in a particular times. Now we have what is called floating point. These floating points help for process optimizations. If you go to my slide, I talk about process optimization in terms of qualities. That's when the process variables comes in. Okay, if I want to fill up these vessels with just 50% of my fluid, what will help me to carry out that task accurately? It is a floating point. It has floating points where it can be programmed. Let's say 50% of my flow rates to fill up these vessels, and that is what you will have. That's what you have. And then we also have a system that is called reset, large and unlarge. So this system can run in such a way that at the end of your production, it can reset itself and continue that production line without human intervention. This is automatically mounted or embedded on a control system or our production line. So now, in terms of our industry and what they are using also, we have different types of softwares also, like C++. C++ is used in C++ is a programming language, and then we have IDE, which is a integrated development environment. That is what this robot is using. This is what this robot is using. We use C++ programming language to write the program, to write a program that which this robot can use to carry out his task according to his programming. So now we can program in such a way that says, okay, carry this product and keep it here, carry this product and keep it here. There are a lot of functioning we can use C++ for, and there are lots of functioning we can use this robotic arm to do also in our industries. So now this ID can be used to write a program to assign different types of tasks to a robot, And now, okay, we we also have a programming language that is functional block. That one functions as ladder logic using in the PLC, and then there are a lot of programming language and there are a lot of PLC programming which you and I as automation engineers can use to carry out productions in our industry. Now that is for what I have been discussing with my experience in the industry. So now we have future trends. There is no automations engineer that will not talk about Industrial 4.0. Industrial 4.0 is what is trending now. Industrial 4.0, it has to do with, in summary, it has to do with using of artificial intelligence and robots to control our production. What you need to know about artificial intelligence is a special package, is a special application that is built or designed, programmed in such a way that it can carry out a task without human intervention, without human controlling it. So this sorry, for example, we have AI softwares which you can use it to interpret different kinds of language. You also use AI to design a lot of videos and the rest of it, etc. There are a lot of AIs. There are a lot of artificial intelligence. Now, this artificial intelligence is going to be in such a way that is a software that is being embedded on a production line. And this guy was going to carry out this work without human intervention according to his programming. That is the work of artificial. That is going to be a work of artificial intelligence. Now, remember that this industrial 4.0, this industrial 4.0 is going to take place. Let us say any moment from now. I listened to a comment with by Elon Musk, which talks about that AI is going to carry out, is going to take over the industry. And the man was asking it, if this AI is taking over this industry, what humans, is it not going to take away opportunities from humans? He said, no, it's not going to take away opportunities from humans. It's going to create an awareness, and it's also going to create opportunities for we humans to upskill ourselves. So now, if I build an artificial intelligence to dust the surface of the HMI, there's a human machine interface where we can interact with our process plan, dust the face of the HMI. You and I can also build a system whereby you can also build to carry out a maintenance on that system also, instead of just to dust full maintenance on it. So this has to do with programming approach. Now, let's look at what Industrial 4.0 is all about in that our materials. Now, Industrial 4.0, also known as the fourth industrial revolution. Revolution is something that is to come. Although it's happening, but it is going to be in advanced, it's going to be in an advanced level. Okay, it's going to be in an advanced level. Now, refers to the current trend of automations, data change, and digital transformations in manufacturing and industrial processes. It can help to exchange data. Now we have what is called SCADA system. SCADA system is just like artificial intelligence. It is being built by automation engineers. These SCADA systems can use to monitor. It can also use to collect data. Can also use to store data in our production line. That's SCADA system. We also have HMI. It's also like a form of artificial intelligence. You can also use HMI, human machine interface, to interact with the plan. You can use it to carry out an operation in the plan. SCADA has to do with supervisory and the supervisory controls and data acquisitions. So now that's it for data exchange. Now we have data transformations in manufacturing and industrial processes. Now, features of industrial 4.0 are we have Internet of the Thing machines, Internet of the Thing machines. We also have devices, and we also have system communication via the Internet of the Things as well, via the Internet of the Things. And then we have artificial intelligence, and then we also have enables predictive. This artificial intelligence, that's one of the features of Industrial 4.0. Artificial intelligence has to do with, it's going to enable predictive maintenance and also quality controls and process optimizations. And then we have automations and robotics. We have automations and robotics. And this is a robot. Now, collective, we also have collective robots, and then we also have autonomous systems work. And this autonomous system is going to work alongside with humans. And we also have cloud computing, and then we have scalable data. We also have scalables for storage. This Industrial 4.0 is going to be in the form that it will be able to store data. No matter how large is the data, it's going to store it for future reference. And then we have process data, and then we have cyber security. This cyber security comes in Industrial 4.0 for protecting the digital infrastructure from threat. There are a lot of internet fraudsters everywhere, because this is Industrial 4.0 is internet based, and it's going to be in such a way that it is internet. It is internet that is going to control the production line. You can even stay in your house with your smartphone, with your laptop, with your any kind of devices to access your industrial plants with this AI, with this Industrial 4.0, without you to even go to the plant. So now, this is going to only take fewer people to work on. It's going to take just fewer people to work on. So if you want to also feel among on this, you need to get yourself upgraded, and you need to also get yourself prepared on your skills for this advanced automations coming up, which is Industrial 4.0.
Just
Want to know more about robots, and then the industrial automations, and how the industry runs, you can also contact me. You can also reach out to me. And concerning the webinar, I see that the internet is also affecting a lot of people. That is me. I know this because I've been in different types, different webinars. I also attend some trainings from some of the companies that book me up. So I know the challenges involved. So the best way to handle a webinar like this is also to design a material. That's why I took my time to bring out these materials for reference purpose. So please you can take your time also. Knowledge is very important. Knowledge is very important. And let's just consider, let's look at what is coming up in the future and engage ourselves. A lot of people are already losing hope that they are going to miss out some jobs opportunity because robot and AI is take over the industry. Meanwhile, it's also creating an awareness and opportunities for us to engage ourselves in new skills and things. Thank you so much for giving me this privilege to interact with your students and your associations. And I believe that maybe it may not be out of 100%, let me just say, any other percent you can rate, but next time I'll make it better with some presentations. Thank you so much. And why it's like because of my work, and thank you so much for finding me worthy of this webinar. I really appreciate it. Thank you so much.
Okay, you're welcome, sir. Thank you very much for it. Maybe if our rate for you is like 100, more than 100%, let's say 200%. Thank you very much, sir. All right, ladies and gentlemen, this brings us to the end of
Sorry,
the insightful.
please let's take some questions, please. It's going to still
Okay,
maybe we can take questions.
do you have anybody that has question? Okay, if there's nobody, me, I think I have a question.
Okay.
Ah, when you are doing your introduction to robotics, you made mention of a lot of things that we can use robot to do. So, though there are a lot of people that are projecting, my question is mainly on security, most importantly the military aspect.
Many on words.
Security, mostly importantly
Okay.
the security, the military aspect of it. How do you think we can use robots to curb insecurity in this country?
We can use robots to stop insecurity in this country. Because by the time that you assemble a robot, it's such you assemble. Let me use a drone. A drone is a robot, right?
Yes.
It can be a drone, and this drone can be built in such a way that it has the sensors to detect the enemies. It has the sensors to detect danger. It has the sensors to detect what is a disastrous society. You can use it to detect and fire back. And that's what and that's for as some cars, vehicles, and then to spread and then to carry out.
Sorry, I
So these are
cannot really hear you very well. Sorry.
okay. Like I said, can you hear me?
Yes, better.
Can you? Okay. Like I said that from your questions, we are talking about robotic arms. So now these robotic arms, you can find them in some of the manufacturing industries, not in oil and gas, some of the manufacturing industries. So this robotics arm, you can find it in the car manufacturing industry, like automotive industry. They use them to spray, they use them to paint, they also use them uh, to assemble and disassemble cars, and also use them to weld our vehicles.
Okay, yes, I get that part. Just to be quick about it, what I was asking of is if there are industries in Nigeria currently that use such machines. I know of one a six-axis robot, but not they've not started operation yet.
Yes, yes. No, that one has not started operation yet.
So there is none in
Now there
Nigeria
are,
currently.
there's none, there's none. And can you hear me?
Yes, I can.
I think what the only automotive industry we have here in Nigeria is the Innocent. I don't think Innocent has such innovations in this company.
Okay, thank you very much.
Last time I checked,
Please, we have other people that have questions. Let us attend to them also. Sorry, Cletus.
Can you hear me?
Yes, sir. Yes, sir. Yes, sir.
They already set a time
Okay.
interval here.
Hello?
Okay. Continue. You can hear you. Fuck.